All right, so looking now that we know some of these basic vocab terms, we're going to look at the big four motion formulas that we're going to be using over the course of the year. All right, so you have these in your notes page here. V equals d over t. That's the formula that we looked at for velocity. And I've given you a key here of what all these variables mean. So d is displacement, v is velocity, and then we can indicate with the velocity using the subscripts I and f whether it was an initial or a final velocity. If you don't see either of those, you're just counting it as the average velocity over the course of time. Maybe it was a constant velocity, so there's no need to indicate initial and final, but we will be using v for velocity in this velocity equals displacement over time formula. All right, a for acceleration and then t for time. Okay, so we need to know what all of these variables mean in order to be able to plug into these formulas when we see word problems. Okay, we already saw this acceleration formula. This is basically just change in velocity over time. And we have a couple other formulas over here. D equals 1/2 at squared plus vit. This is a useful formula if you have an object that's changing its velocity somehow. You can still calculate the total displacement that it covers during a given time. And then here we have vf squared, this squared sign should be up here, and up here equals vi squared plus 2ad. All right, so we're looking at the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. All right, so if you want to fill in your notes what all of these vocab terms mean, I've given you spots there to do that. So we're going to be using all of these formulas, and we need to identify what each variable means so we can pull that information out of the context of word problems. All right, so when we're solving word problems involving motion, or really any word problems this whole year, we're going to use the same 3 steps every time. The first step is to make a list of all the information you're given in the word problem. So if you're given information about a car's initial velocity or something like that, and maybe the distance that it traveled, we want to pull all of that information out of the problem and then make a list of it in terms of its variables. So if we had a given velocity or an initial velocity, we would say initial velocity equals, let's say it's 20. And then let's say we're given the amount of time that it took. We would say time equals 10 seconds or something like that, right? So all we're doing here is taking the information from the problem and we're going to make a list of it like this in terms of our variables. So then it becomes a lot easier to see where we have to plug in what information. All right. One important thing to note here is make sure that in your list of variables you include the variable that you're being asked for in the word problem. So if it asks you to find what was the total distance traveled, then we're going to add distance down to our list and just leave a little question mark because we're trying to find it. Or whether this was, if you were trying to find velocity, then you would list velocity as a question mark. But you do want to include it in your list because then we know these are all of the variables that our equation needs to involve, and it'll help us pick out which equation to use. All right, so first step is make a list of all your variables, including the one that you're looking for. The next step is to take a look at your list and see which equation would actually work using the information that you have and need to find. All right, and we'll look at an example of that in a second. And the last step is to plug in all of the information that you have and finally solve for whatever variable you're trying to find. All right, so the 3 steps: make a list, choose which equation to use, plug in, and solve. All right, so list, equation, plug in, and solve, and we're going to use that same process for every word problem. All right, so let's try and put this into practice and look at an example here. So we have a word problem here. A car is moving at positive 25 meters per second, and then it slows down at a rate of 4 meters per second squared. This 2 should have been an exponent here as well. All right, so negative 4 meters per second squared is the acceleration, and we can tell that it's an acceleration because there's a keyword here, slows down. All right, so slowing down means that we're changing the velocity, and if that's the case, then that means we're looking at acceleration because acceleration is a change in velocity. So how fast is this car going after 5 seconds? So we've got a whole bunch of information here we can try and parse out. So we're given an initial velocity for the car, right? Because this is how fast the car was moving to begin with. So we can list that. Initial velocity is 25 meters per second. And then we also know that it slows down at a rate of 4 meters per second squared. Maybe I'll put that in a different color. That's going to be our acceleration. So our acceleration is negative 4 meters per second squared. And then we also know here, how fast is it going after 5 seconds? So 5 seconds would be a time. So we plug our time in as 5 seconds. And the last thing to include in our list, remember, is what variable we're actually looking for. So how fast is the car going? That's really asking about a velocity. And we're looking at the velocity at the end, so this would be our final velocity. All right, so pulling this information out of here, you have to read very carefully and critically. So the car moves at 25 meters per second. We knew that that's what it was doing to begin with, so that's our initial velocity. And then the car slows down, and the key word there was slows down because it indicates a change in the velocity. Any change in velocity is acceleration. And then we know how fast is it going after 5 seconds. So that 5 seconds is a time, so we know to list that as time. It says how fast is it going after the 5 seconds, so we're really looking for a final velocity in our list. All right, so we've come up with a list like this, and now what we want to look at is out of the motion formulas that we have, which of them would fit with the information that we were given and the information we're trying to find. So what we want to do here is look and see which of these equations fits right. So if we look at, for example, this last equation here, VF squared equals VI squared plus 2AD, if we look at this equation and try and plug our numbers in, well, we have VF involved. So VF is involved, so that works. We have VI involved, so that works. And we have acceleration, so that works. But then when we have to use distance in this formula, distance is not a part of our list down here. All right, so that tells us that this is not the right formula to use. So if we look at this formula, same issue, right? We're involving distance or displacement in this formula, and it's not in our list of information, so we know not to use this formula either. We could look at the V equals D over T formula. That is okay, but we're missing the initial and final velocity aspects of it. This formula is only for a constant velocity, so it's not going to work here. But then if we look at this acceleration formula, we're looking for A, which we have, VF, which we also have, VI, which we have, and then T, which we have as well. So all the parts of this A equals VF minus VI over T formula are things that we have involved based on the list that we made. So now we're just going to take all the information from our list and plug it in to this formula. So A we have is negative 4 meters per second, so I'm just going to come and plug in down here. So we have negative 4 meters per second squared equals VF, which is our unknown, so we can leave that as a variable, minus VI, which is 25, and then over time, which was 5 seconds. Okay, so all we've done here is taken our list of information and plugged it into the formula with each variable going into the appropriate spot, right? So VI goes into the VI spot in the formula, A goes into the A spot in the formula, T goes into the T spot in the formula, and that's how we plugged all these numbers in here. All right, so the final step is to solve our equation. To solve this, we would multiply both sides by 5, right? That would give us negative 20 equals VF minus 25, and we could then add 25 to both sides, and that would give us a final answer of 5 for our final velocity, and that would be in meters per second. All right, so follow these steps every single time. I even made a little acronym down here for you: list, equation, plug-in, solve. So we made our list here of all the information that we could pull out of the problem, and then we chose which equation to use based on the list that we have and what our list of information fits with, and then we plugged in our numbers and solved. So you could think of this LEPS, list, equation, plug-in, solve. Hopefully that helps some of you remember this. All right, so we're going to look at one more example here. So we have Joe here running at a velocity of 4 meters per second. So we know off the bat, anytime we see a number, that's something we probably want to use, right? So it tells us his velocity is 4 meters per second. And then he accelerates at 2 meters per second for a time span of 3 seconds. How fast is he running now? Okay, so we have a whole bunch of information we can pull out here. So if we start taking it one by one, the first thing is we have this velocity of 4 meters per second. That's the velocity that he started at. So that's going to be our initial velocity. All right. And then he accelerates at 2 meters per second squared. So that was worded very nicely. Tells us that 2 meters per second squared is our acceleration. And then we have a time span of 3 seconds. So we know our time for this problem is going to be 3 seconds. And then the last thing here is the variable that we're looking for, which in this case is how fast is he running now, so that would be our final velocity. And that's our unknown, so we'll be looking for that when we go to plug into our equation. All right, so again here, we have 4 variables involved in this problem, and we have to try and pick out which formula is appropriate to use with those variables. So in this case, we have initial velocity, acceleration, time, and final velocity. This is actually going to be the same equation as we used before, because again, distance is involved in both of these equations, but we don't have distance or displacement as a variable in our equation. So now we know we have to use this formula. Again, this formula uses displacement as well. That does not work. So we know we have to use this equation. We're going to see how our numbers plug into that equation. So in this case, our acceleration was 2 meters per second squared. And that's going to equal our final velocity, which is what we're looking for. So we'll again leave that as an unknown, minus our initial velocity, which in this case was 4 meters per second, over our time, which in this case was 3 seconds. Okay, so same thing to solve here. We're just going to try and isolate our unknown variable, VF. So if we want to solve this, we're just going to multiply both sides by 3. That would give us 6 equals VF minus 4. And then to solve, we would add 4 to both sides of the equation. So we'd get VF equals 10 meters per second. All right. So when we go to solve these equations, we want to list first. So we made our list of variables. That's step 1. And then pick which equation to use. So up here we went in and saw which of these formulas would fit with the information that we have. So we picked which equation to use. That's step 2. And then we plugged into our equation. That's step 3. And then we solved it, which is step 4, and get ourselves a final answer. All right, so list, equation, plug in, solve. LEPS. Every time, just do LEPS. All right, well, thanks for watching this video, guys, and good luck doing the rest of these practice problems, and please come see me if you need help. Thanks, bye.